Have you ever looked up at the night sky and wondered where it all came from? Where did the stars, the planets, and even the space between them originate? The answer takes us back to a time before time itself, to a moment of cosmic creation. In the beginning, there was nothing we would recognize. No light. No space. No time. Everything that would one day become our universe, every star, every galaxy, every single atom in your body was compressed into a point of infinite density and temperature, a state so extreme it defies our current understanding of physics. This is the story of how everything began. This is the story of the Big Bang. About 13.8 billion years ago, our universe burst into existence. Now, when you hear the term Big Bang, you might picture a colossal explosion, like a firework detonating in the vast emptiness of space. But that's a common misconception. The Big Bang wasn't an explosion asterisk in asterisk space. It was the expansion asterisk of asterisk space itself, happening everywhere, all at once. Imagine an infinitesimally small, unimaginably hot and dense point that suddenly began to stretch, carrying everything within it along for the ride. In this primordial state, the fundamental laws of physics as we know them simply didn't apply. It was a universe of pure, chaotic energy. But as space expanded, it started to cool down. This cooling process was the critical step that allowed the universe to evolve from a chaotic soup of energy into the structured cosmos we see today. It was in these first moments of cooling that the very foundations of matter, energy, and the forces that govern them were laid. The stage was set for the formation of everything that would ever exist. So, how do we know all this? It sounds like a fantastic story, but it's not just a philosophical idea. The Big Bang is one of the most robust and well-supported theories in all of science, backed by multiple, independent lines of hard evidence. Let's start with the first major piece of evidence: the expansion of the universe. In the 1920s, the brilliant astronomer Edwin Hubble made a groundbreaking discovery. While observing distant galaxies, he noticed something peculiar. The light from these galaxies was stretched out, shifted towards the red end of the spectrum. This phenomena, known as redshift, is a cosmic equivalent of the Doppler effect. Just as the pitch of an ambulance siren drops as it moves away from you, the light from a receding galaxy stretches to longer, redder wavelengths. Hubble realized that nearly every galaxy he looked at was moving away from us. And even more astonishingly, the farther away a galaxy was, the faster it was receding. This wasn't because we were at the center of some cosmic explosion pushing everything away. Instead, it revealed that the very fabric of space is expanding, carrying the galaxies along with it. If the universe is expanding today, it means that in the past, it must have been much smaller, denser, and hotter. By rewinding this cosmic movie, we arrive back at that initial, singular point. The second crucial piece of evidence is something called the cosmic microwave background, or CMB. In 1965, two radio astronomers, Arno Penzias and Robert Wilson, were working with a large radio antenna and kept detecting a persistent, faint hiss of background noise. No matter where they pointed their instrument, they tried everything to eliminate it, even cleaning out pigeon droppings from the antenna, but the signal remained. What they had accidentally stumbled upon was the afterglow of the Big Bang itself. This faint glow of microwave radiation permeates the entire universe, coming from every direction in the sky with almost perfect uniformity. It's the leftover heat from a very young universe, a snapshot from when it was only about 380,000 years old. Before this time, the universe was a superheated, opaque fog of charged particles, but as it cooled, the first atoms formed, and light was finally able to travel freely through space. The CMB is that very first light. Stretch at over 13.8 billion years of cosmic expansion from brilliant, visible light into the cool microwaves we detect today. It's the oldest picture of our universe we will ever have. A third pillar of evidence comes from the chemical makeup of the cosmos. The Big Bang theory doesn't just describe the expansion, it makes specific, testable predictions about what the early universe was made of. The models predict that in the initial fiery moments, the simplest elements should have formed in very specific ratios, primarily about 75% hydrogen and about 25% helium, with tiny trace amounts of lithium. When astronomers look out at the oldest stars and most pristine gas clouds in the universe, What do they find? An abundance of elements that matches the predictions of the Big Bang Theory with stunning accuracy. These 3 lines of evidence: the expansion of the universe, the cosmic microwave background, and the abundance of light element soul point to the same origin story. So let's rewind the clock to the very first moments after the Big Bang. In the first fraction of a second, an event of unimaginable power occurred. Cosmic inflation. In a sliver of time so small it's almost meaningless, the universe expanded exponentially, growing from smaller than an atom to larger than a galaxy. This hyper-expansion, faster than the speed of light, smoothed out the universe, explaining why the CMB is so incredibly uniform across the entire sky. Within the very first second, as the universe continued to expand and cool, fundamental particles like quarks and electrons materialized from pure energy. A few minutes later, the temperature had dropped enough for protons and neutrons to fuse together, forming the nuclei of the first elements, hydrogen and helium. For the next several 100,000 years, the universe was a hot, dense, and foggy plasma. It was still too hot for stable atoms to form, as high-energy photons would immediately knock electrons away from any nuclei they tried to bond with. Light was trapped in this cosmic fog, unable to travel far without scattering. Then, about 380,000 years after the Big Bang, the universe reached a critical milestone. The temperature dropped to about 3,000 degrees Celsius, cool enough for electrons to finally combine with nuclei and form the first stable, neutral atoms of hydrogen and helium. This event is called recombination. Suddenly, the universe became transparent. The photons that had been trapped in the plasma were now free to travel unimpeded through space. This liberated light, this first dawn, is what we now see as the cosmic microwave background. With the formation of atoms and the release of light, the universe entered a new phase, a period we call the cosmic dark ages. For hundreds of millions of years, there were no stars to illuminate the cosmos. There were no galaxies, just vast, silent clouds of hydrogen and helium drifting through the expanding darkness. The universe was a quiet, lonely place. But it wasn't static. An invisible force was already at work, silently gathering these primordial clouds together. Gravity, the master architect of the cosmos, was beginning to pull matter into denser and denser clouds. And from this darkness, the first points of light were about to ignite. The stage was set for the birth of the very first stars. In the next chapter of our cosmic story, we'll witness how gravity transformed this dark, simple universe, sculpting the first stars and galaxies from the primordial gas and beginning the journey towards the rich, complex, and beautiful cosmos we inhabit today. Thanks for watching, and be sure to subscribe so you don't miss part 2, where we'll explore the birth of the first stars.